Hello, and welcome to this session on Red Hat Advanced Cluster Security Vulnerability Management. I'm Chris Porter. I'm a Senior Principal Solution Architect. We're going to be walking through a number of topics about using vulnerability management within Advanced Cluster Security version 4.2. First, we'll give you a little bit of an introduction to vulnerability management. What is it? Why it's important? We'll talk about the mechanism for scanning container images in ACS, including some of the configuration that you might have to do to get this running. We'll talk about using the user interface, the vulnerability management dashboard in its various versions for understanding and exploring vulnerabilities in running deployments. We're going to look at the scheduled vulnerability reports. This is an automatically emailed or downloadable report that you can use to get a summary of vulnerability issues in your environment. And then we're going to talk about shifting left. We're going to talk about using the ACS command line to integrate within a CI/CD pipeline and then use those settings in policy to follow best practices for vulnerability management. So to start with, vulnerability management is identifying bugs in software components. This is where an attacker could gain unauthorized access to your applications by exploiting those bugs in software. Thousands of them are discovered every year. Almost every software component that exists on Earth is impacted by these at some point. And it's important that you have a process to identify and resolve these vulnerabilities as early as you can. Now, Advanced Cluster Security, of course, provides a built-in vulnerability scanner, and its job is to break down the container images, which are made of layers, identify the components in those layers, and then map the components to the known vulnerabilities from sources such as the National Vulnerability Database. Now, vulnerability scanning occurs in ACS either when you make a request, on demand using the command line, or when an event occurs, such as a Kubernetes deployment is created in your cluster. And ACS uses that event to then go and pull down the relative image layer data and provide vulnerability mapping for it. Now, ultimately, your end goal here should be to use ACS to prevent someone from deploying container images that have these high scoring vulnerabilities, which are fixable, right? Meaning that upstream, there are available fixes for those vulnerabilities. There's a default policy in ACS that meets this requirement. The goal should be to get there. Now, maybe not on the first day, but you're going to want to progress your adoption of ACS so that you are preventing the deployment of these container images and giving the teams that own those applications the information that they need to go and understand and resolve those problems. Now, scanning images is part of the mechanism here. The container images are composed of layers, as I mentioned earlier. A layer is essentially a tar archive of a file system. And the container file, or you may notice a Docker file, specifies the commands that will modify that file system, either adding or removing a component. When a layer adds a component, those components can be mapped into vulnerabilities. And the ACS scanner does all this automatically. It treats things as images, but under the hood, it's thinking about things in terms of the layers. It's going to download that layer archive. It's going to open it up and identify all the components in each. Now, once a given layer has been broken down in this way, it'll maintain the mapping of that layer's components to the vulnerabilities. It actually doesn't go and scan it again. For performance reasons, we cache the results of a given layer. We know the components that are present. Layers do not change. And so we can update the list of vulnerabilities associated with a given layer over time. Now, within ACS, this process is mostly automatic. You'll find that a fresh installation of Advanced Cluster Security will automatically discover all your running deployments, the images that they use. It will reach out to the registries where those image layers are stored, download the layers, and provide the results. So you may see all of those results populated right away. But there's some additional configuration that you might have to do. One would be to give ACS some credentials to access image registries in your environment that are protected by authentication. In many cases, ACS's scanner will grab these automatically, but in some cases we need to check to make sure that we have all those image registries configured. Certainly the UI will have all of its data live and available in the UI as soon as those vulnerability scanning processes have happened. You might also want to configure things like scheduled reports in order to send information out, different formats to understand the scope of the problem. Next, you'll want to use the ACS policy engine to actually start setting those notifications to set them what we call the guardrails. This is where enforcement will be done. It's very easy to adopt ACS policies in a slow pace so that you're not disrupting things, but teams become aware that there is a responsibility that they have. Again, the final goal, though, should be to set up and use the ACS command line tool in a CI/CD pipeline. This will deliver information to the teams that own these applications that they have vulnerabilities to address. It'll prevent them from advancing that CI/CD pipeline. And the policy here can also be used to prevent those deployments from happening until those issues get resolved. All right, let's take a look at some of the configuration that's required for vulnerability management within ACS. If you see your dashboard shows image results like this, ACS has already got the configuration that it needs. We can take a look and make sure that integration configuration is complete by navigating to the platform configuration menu on the left and then down to integrations. The first thing that you should see among all the registry and scanner integrations is integration up here in the top left for the StackRox scanner. This is the scanner that comes default with ACS. It should be configured automatically. There should be nothing else for you to do here. It's configured as both an image scanner and a node scanner, and we want to use this. The other integrations that you'll see will be for registries in your environment. Some of them are configured by default. There are integrations built in for public registries that don't require authentication. You may see ACS having created other registry integrations automatically based on pull secrets that it found within your OpenShift cluster. So don't be surprised to find some here that show a username, that show an endpoint that's in your environment, because ACS has discovered those automatically. If one is missing, if there is an integration that's not available, maybe it's a JFrog Artifactory server in your environment, maybe it's a cloud-hosted registry, maybe it's a private repo on Quay.io, you can add those here. Each of these types of integrations is going to require a different set of configuration. In common, they'll all have setups for giving it a name, the requirement to just name it an arbitrary name, to give an endpoint for this, whether it is a host name in your environment or a public endpoint for a registry in the cloud. You'll be provided some sort of authentication. You need to provide either a username or password, a token, a secret key, or in the case of cloud provider credentials, to use things like assumed roles or EC2 instance roles, for example, for Amazon. Now, you could test these integrations when you create them. This just checks that the authentication is successful, that the endpoint is available, and then when you save it, ACS will use that integration. Now, when you have an automatically generated integration, one that was gleaned from a pull secret, or you're going to use a private repo on a server like gcr.io, you won't be able to delete these integrations within the product. However, if you do create a custom integration, ACS will always prefer to use the custom integration over the default auto-generated one. So don't worry about deleting them. Just create the proper ones, and ACS will use those in all cases. Okay, now that we've got ACS configured to use the registry integrations that we created, we can see that it's retrieving image vulnerability data and applying the rules that we specified here. We can see some of the populated data here on the dashboard, but let's navigate down to vulnerability management. Now you're going to see that there are two sections for this, labeled 1.0 and 2.0. At the time of the recording of this video, the work is going on to migrate to a new user interface, which improves performance, provides better access to data. The vulnerability management 2.0 may be all that you see in yours, depending on when you're watching this video. The purpose here is to show us globally the image vulnerabilities, the images themselves, and the deployments, so we can drill down and look at this data in any way that we like. You can filter on all this as well. So if you're looking for something specific, like a particular deployment, you can go in and choose that deployment and see the results for that. You can drill down on all of this data. As you'll see, there's quite a few levels here where we can get to the details of the severity, the fixable status. In the case of things like Java or Python vulnerabilities, you'll actually be able to see the file location where this vulnerability was found and the Docker file entry where this was added in. This is a huge amount of data, and there's lots of different ways to summarize it. You can also search through this. One of the most important requirements we want to meet is the need for when there's a new vulnerability out there in the world, that understanding the impact of that in your environment. So if I look at something like Log4Shell, we can find that we do have this in our environment. We have one image that's affected. As I look through the images, I can go and drill down again and see, where that vulnerability is impacting my environment. Luckily, I don't have any running deployments for this, but if I do, I can see those here as well. Now, I mentioned reporting because a good way to get summaries of all of this is to create a scheduled report. So as we look at the vulnerability reporting, I've got one that's already configured here, but let's go ahead and create a new one. We're going to have this as a Chris's projects, And normally I put a description in here. Now there's some values that I can choose here for what I want to include in this. Normally by default, we're just looking at the critical and important ones. These are the ones that are most likely to be exploited or have the biggest impact if they're exploited. And so I'm going to focus on just the criticals and the importance. Of course, I want to think about fixables or unfixables. ACS will always show me both. Will always show the status of all vulnerabilities, whether or not they're fixable. And fixable means that there's an upstream package version that does not have the vulnerability in it. Here, we're just going to focus on the fixable ones. I want to be productive. I want to show my development teams what they can actually fix. I want to look at all images. We can just look at the ones that are active, meaning that they're deployed in use in a cluster somewhere, or I can also include the images that I've set up in a watch. I can also make sure that these reports are either all time or are incremental from the last time that I ran the report here. I'm going to configure a report scope, and scopes are using collections, and I can go out and create a collection from here or manage those separately. A collection is a set of deployments specified by deployment name or labels, by namespace name or labels, or by whole clusters here. So if I choose a particular application in this case, I'll get a report on just the images in use by the deployments for that particular application or namespace, however I define it. Now, I can add a delivery destination, meaning this can be sent via something like an email notifier. I can also send this to specific users or distribution list here. I can also just have it available for download. I don't necessarily have to have this emailed out as an attachment. Finally, I'm going to select the schedule for this. I can do this on let's say a daily basis by choosing the weekly option, and then choosing the days that I want to have this sent out. And then finally, I'll get a preview for all of the results that I'm going to get. This is a kind of a preview of the format that we're going to see in a CSV spreadsheet format, basically, once I go ahead and produce this. Now, once it's created, you'll see that I have options for running a report now, generating a download for a given report, so they don't have to wait for the schedule to necessarily tick on by. Okay, let's build a ACS system policy with criteria from vulnerability management. System policies are how we act on violations, on matching criteria in our images. In this case, we're going to look at how vulnerabilities in the container image used in the deployment can be used to invoke the policy actions of like enforcement and notifications, can give us reporting and visibility, and then finally can help to guide teams towards the solution to those issues. Now, the ACS system comes with a bunch of default policies. Those system policies are really useful, including one here that's it's called fixable severity at least important. What this means is that we're looking for vulnerabilities in images that have a severity of either important or critical. So these are pretty high-ranking, high-scoring CVEs that are very serious, and they're fixable, meaning that upstream, vendors like Red Hat have provided a fix for the component that resolves that vulnerability. And so this is the vulnerabilities that you can get by automatically updating components within your images as part of their build, or someone could manually address by updating a Docker file and rebuilding those images. Here, this is a global policy, meaning that its scope is wide open. It covers all images in all deployments. Now, to get started, what I would recommend is something very similar to this policy, but maybe scoped a little bit more narrowly so that we don't introduce enforcement when teams aren't ready for that. Now, to do that, I'm going to choose to clone the policy. I'm going to give this another name, maybe just adding the fact here that I'm going to be enforcing this particular policy so that people know that this is a version of the policy that is going to be enforced. You shouldn't modify the default policies. And in fact, you won't be able to modify the policies too significantly because they could be overwritten if we ever change the policy in a release of ACS. I'm going to keep the severity where it is. I'm going to leave the categories as they are. I can define my own custom categories here in this policy, and I'm going to leave the rationale and guidance the same here just for the purposes of this demonstration. On the next page here, I have the policy behavior that we are going to modify. You can see that this is effective in both build and deploy time, which means that we're looking during the CI/CD pipeline, during a build process for this container image. And we're going to see more of that in the next section of this video, but also at deployment time, which is where a deployment has already happened or is happening, and we're examining the image contents here as part of that deployment. I'm going to turn on the enforcement here. I'm going to turn on both the build and the deploy time enforcement. Build here allows me to put the notification and the failure right in front of the developers where they're working so that they can see that failure, understand the source of the issue, and address it and move on. The deployment time protects the OpenShift cluster. This uses the Kubernetes admission controller to prevent the creation of a deployment object when the image that's in it doesn't meet my compliance requirements. Now, this is enforcement's a pretty big step, and it does interrupt the flow of application development. So while I'm going to leave the criteria the same it is, I'm going to think about fixable vulnerabilities where they're either important or critical. You could certainly modify these. I'm going to scope this policy so it's more narrowly focused. And there are two ways to do scoping in a policy here. One is to restrict to a specific scope. Another one is the opposite, basically, to exclude specific scopes. Obviously, here we're going to go with an inclusion scope. It looks like I have to select a cluster. You don't actually have to select a cluster unless you want to include the entire cluster. But today I'm just going to focus on a particular namespace. I want to start this with maybe one team that is already aware of vulnerability scanning. They know that they're going to be subject to this kind of rule. I don't want to disrupt the entire environment. I just want to focus on a particular namespace. And so I'm going to put this rule in place just when that namespace matches. Before I save this, you see I get a preview here that there are already violations of this. In other words, that if I were building this, if I were deploying this right now, this image within this deployment would not meet the requirements for entry and would be rejected. When I save that, this immediately becomes effective. And in fact, if I navigate now up to the violations page here, we should start to see some of these rules showing up here. A violation is an instance where that policy's criteria matched, and it records the details of that. Now, because this is a build and deploy lifecycle policy, it will not impact already running applications. So if I try to deploy this application again, these violation criteria would cause that to be rejected. But since this is already running, we won't see that impact. That's a safety precaution here. We don't want a new policy or a new vulnerability discovery to go and impact something that's already running. You'll see that the violation details give me information like the enforcement, for example, and we know that enforcement is now enabled. We see the details of the deployment, including things like the image configuration that caused this, any of the networking and security context configurations here. And then lastly, the policy, which explains to me why this matched, why it's important, and what I need to do to resolve that. In the section with CI/CD pipeline, we're going to see how this same information can be provided to developers in the development environment that they're working in today, so that they'll see the relevant information about the matching vulnerabilities so they can get an easy start on resolving those issues. All right, for the last part of our video, we're going to bring together all the topics that we've seen so far. We've configured ACS to reach out to registries to be able to retrieve image layer data. We've seen the vulnerability management that has given us information about those CVEs, and we've created a scheduled report that allows us to summarize and email out those vulnerability reports. Lastly, we created an ACS system policy that allows us to enforce those rules. And here we're going to see that use of that policy in a CI/CD pipeline. So here I am in an OpenShift console because I'm going to create an OpenShift pipeline task and pipeline to evaluate images as part of the build process. The configuration that I'm using here is part of a GitHub repo, and we're going to start with a cluster task here. I've got the code here that you can then download and paste, but it's pretty simple. Now, other CI/CD products are supported with ACS. Don't have to be using OpenShift pipelines, but that's the example that I'm using here. And you'll find configuration for other CI/CD pipelines, examples like this that work with other tools available on GitHub. It starts with a couple of variables. This pipeline task needs a central ACS installation to talk to. It needs an API token to authenticate. That authentication token needs to have at least CI permissions. The task itself has just a couple simple steps. We're going to download the rockctl command line into the pipeline container. We're going to make it executable. And then we're going to run this rockctl image check. This is going to take as an argument the image that we want to scan. And then it's going to provide us with the pass or failure status as well as some other output that we'll see. The next thing that we need to do is to create a pipeline, which makes use of that. We're going to create a pipeline, again, here using YAML that I have prepared already. Again, these are going to be available on GitHub. The arguments here are just simply the things that we saw earlier, the image name as a string. We also have the parameters for the API token and the central endpoint specified in this case in a secret. There's other ways to do this, but passing these in as a secret allows us to keep them isolated here. Again, I'm going to create that pipeline, and then we're going to go ahead and run this pipeline against an image of our choice. Running the pipeline is pretty simple. We're just going to click Start Pipeline. We're going to provide the parameter here. Now, this is not the way that you would do this. You'd normally make this part of the run where the image name is created from a previous step, but we can start this here and see the results. It's going to take a couple of seconds. And now we have our results, and we can see we have a failure. There's that policy that we created earlier, which is designed to evaluate images and enforce the rule. This is designed so that the teams have an understanding through that logged output here. They can see the failure, they can quickly get to the source of the problem and address it. The goal is to give the development teams that own this application everything that they need to understand to follow the guardrails that you're setting as part of the system policies. Every vulnerability in this case is listed as the identifier, the scores, the component name, and the version that they're currently on and the version that they need to get to resolve this particular vulnerability. Now, there are other policies in here that are impacting this particular deployment, but they're not fatal. They're not treated as a failure of the build process. It's the vulnerability policy that we created that causes that check to be in place. Hopefully you've enjoyed this quick tour through vulnerability management. Look forward to seeing you on the next video.